Okay, so let's start today's one-to-one talk series about the preferred topic today is linear transformation. So linear transformation is a very well celebrated topic in linear algebra. So before going into the details of the topic, we just first want to mention a few things about this one-to-one lecture series. First of all, it's not a class about any specified targeted competitive exam. We must clarify this first of all. It's entirely a very informal discussion series. Entirely, it will just go on and on like just like an Bengali Adda session or something like that. And the mathematics would take just back seat. We'll just mostly discuss about various things, various topics, maybe a few problems, maybe a few programmings. We'll discuss everything in this one-to-one talk series. It's like an informal Adda, as I've said, completely. It's not a very serious class, or nor I would try to teach you about very many interesting, important things. No, I'll not giving you any lecture. For lecture, we have our in-house classes for that, where we do serious lecturing, because YouTube or any social media is not a very great platform to deliver serious lectures. Because in most of the YouTube videos, we can learn, but we really cannot learn in depth, really. Because in order to learn in depth, you have to go through series of classes, one-to-one interactions, then you can learn a topic quite extensively. Just for example, I often see many videos like learn Python in 3 days or in 3 hours or in 12 hours. It's not that easy. It's not that easy to learn Python in that only 12 hours or something. Or it's really impossible to understand the notions of any particular probability distribution problem in just 10 to 12 hours of lecture listening. It takes a lot of practice. It takes a lot of days. You have to comprehend the topic, and then you can only delve deeper into any session. Okay, so we are just keeping this one-to-one interactive session as our informal adda. So you can drop in any kind of question if you have in my way. Let's check whether is there any comment or not. Okay, fine. So today I told you that I'll discuss about linear transformation. Now, what is meant by linear transformation? Now, whenever I'm saying transformation, that means I'm moving from one place to another, or I'm taking a different shape. Okay. So what is linear transformation? What's so special about this thing? And why it's so much popular in linear algebra? And it has immense application in multiple fields, really. So let me just give you a very basic idea about linear transformation. Okay. So I'm just turning off my video for a while, and I'm just turning on my white screen. Okay. I guess my screen is now visible to everyone. Let's try to learn a few tricks and techniques of linear transformation. Okay. Now, I think you all know about function, right? Fx. From this notion, just move on to the notion of linear transformation. Pretty simple to understand. Just pardon me for a second. The screen is not working properly. Yeah. So let's just start from a few basic understanding. a vector. So X curl is an n-tuple vector. It has n components, x1, x2, xn. Okay. Now, if x1, x2, xn, they all are real number, then they may belong to Rn. Okay. Okay. Now we are just considering a function of x1, x2, xn, like summation xi. So this vector has n components, but this thing has only one component, so it belongs to the real plane. So if I make such a transformation, then just I'm jumping from n-dimensional real plane to one-dimensional real plane. Now statistically, I'm very bad at mathematics, really. There are a lot of people, they are very great at mathematics, but I see everything statistically. That's my habit. Being a stat student, I believe stat is the foremost thing by which I can explain you everything. Okay, it's not maths for me entirely. Anyway, so what is the statistical advantage of such a jump? Initially, I was into the n-dimensional real plane, and now I'm in the one-dimensional real plane. So what is the great advantage I'm having? Mathematically, that's a jump, that's a transformation. But statistically, what is my advantage? See, data is gold. In the modern science of data, we say that data is gold. Okay. Suppose, for example, that's a data set. Okay. x1, x2, xn, they are the collected data points. But to deal with such a high dimensional data is quite cumbersome, maybe. Suppose n is 1 lakh. So we have a 1 lakh dimensional data. Very tough. Just suppose you have an Excel sheet where you are given 1 lakh dimensional data. Quite a tough thing to comprehend, right? But what we are doing just one simple transformation from this x1, x2, xn. I'm just considering this simple summation xi. So just magically, this 1 lakh dimensional data is now becoming just one dimensional data. This thing is called, we are just reducing the dimension of the data set. Okay. And statistically, any day, one dimensional data is quite easy to use over any high dimensional data. That's quite a valid statistical problem. Okay. So statistically, transformations are very important. Quite important. Now, how this idea of transformation emerges in linear algebra? That's quite a very intriguing question. That why this subject is very grippy. In today's lecture, I'll be discussing a few technicalities, but in future days, maybe in some other class, I'll tell you how this idea of a linear transformation can be converted to different ideas of machine learning. Obviously, I'll have some other experts on board who will do some live programming to demonstrate how linear transformation can be applied to different aspects of machine learning. Machine learning is quite popular and famous right now, we all know, but the background is entirely mathematical and statistical also. Okay. Anyways, I'm very bad at math, I'm saying initially, really. So I'm just starting off with one or two examples. Let's see. Before jumping into the concept of linear transformation, let's discuss a few forewords about vector spaces. You may thought that vector space is a home for vectors, like that's a vector space, it contains a few vectors, maybe, etc. You may think that vector space is a home for several vectors. But as you know, maybe the school is like home for a few people like us, maybe for all of you. But to be in the school, you have to obey some rules. That's called discipline, right? In order to be inside a vector space, vectors must obey a few rules. There are a lot of rules vectors must obey in order to stay at vector space. I'm just talking about two rules. The first rule is called vector addition rule, and the second law would be called scalar multiplication rule. Now, V is a vector subspace. I'm not going into vector space. I'm just sticking myself to vector subspace. V is a vector subspace. Now, when can I call this V as a vector subspace? X curl is a vector that belongs to V. Y curl is a vector that belongs to V. Then they are saying that X curl plus Y curl must belong to V. This is called the closure property of vector addition. We are saying that V is closed under vector addition. Okay. And the next property is if X curl belongs to V, then lambda X curl, the vector is being multiplied by some scalar quantity lambda, then this thing also belongs to V. This is called closed under scalar multiplication. Okay. So V is a vector space or vector subspace. For the time being, just consider V as a vector subspace. V is a vector subspace if it obeys these two closure properties. The first one is it has to be closed under vector addition. And the second property is it has to be closed under scalar multiplication. Okay. Now I'm coming to the point of linear transformation. Just look at the main idea. Now, just consider V and W. V is a vector subspace. And W is another vector subspace. Okay. Now a linear transformation is a mapping from V to W. But the mapping is not an ordinary mapping. The mapping has to obey a few rules. This mapping is called a linear transformation. If number one, T of alpha curl plus beta curl can be written as T alpha curl plus T beta curl. Okay, where alpha curl and beta curl both belongs to the domain vector space V. We are mapping from V to W, so V is the domain vector space. That's your first criterion to be a linear transformation. And the second one is T of C alpha curl, it will be C of T alpha curl. Once again, alpha curl belongs to the domain vector subspace V. If this mapping obeys these two properties or qualities, then we can call this mapping as linear transformation. As simple as that. You may have multiple types of mapping from V to W. We don't call them linear transformation until and unless they are obeying these two particular properties. So linear transformation, they are very specialized or specific mapping obeying these properties. Okay. Now, let's check some problems. Anything must be validated using some problems. And after solving these problems, I'll tell you what kind of problem you may face in JAM. There may be a lot of problems of this particular topic in JAM. Maybe in each year I see hardly one question comes about this topic. So apparently you may think that for JAM it's not a very important topic, but life is not about JAM. Okay. In order to get bread and butter in life, studying for JAM is not enough. Okay. That's one fake propaganda you will face everywhere, that JAM is very important. Getting into ISI is very important. Otherwise, life is just like hell and so on. These are bullshit. They are just fucking businessmen, nothing else. Okay. Just like that. Don't rely upon businessmen. Rely upon your own merit. That's the main thing. Anyways, let's solve one problem. We are considering one transformation from two-dimensional real plane to two-dimensional real plane. And the transformation is given as this. Txy equals to x plus y and x minus y. That means what? That means T22 would be 2 plus 2, 4 and 0. Just like that. Two components here, two components here. So it's a mapping from two-dimensional real plane to another two-dimensional real plane. It's a mapping for sure from R2 to R2. But is the mapping a linear transformation? That's our question. Let's check. Let's check. Okay, so let's take alpha curl, a two-component vector. So definitely alpha curl belongs to R square. Two component, these all are real numbers. So definitely alpha 1, alpha 2 belongs to the two-dimensional real plane. Let's consider another vector, beta curl. Once again, let's take it as a two-component vector. Beta 1, beta 2 also belongs to R square, right? Okay. Now, how to check? You have to check for 2 points. The first point is whether T alpha curl plus T beta curl is individually T alpha curl plus T beta curl. That's the first query. Let's check. Now, what is T alpha curl plus beta curl? Now, alpha curl plus beta curl is just adding up two vectors, alpha 1, alpha 2. plus beta 1, beta 2. That's simply element to element addition. Alpha 1 plus beta 1 and alpha 2 plus beta 2. Right? So T alpha curl plus beta curl is nothing but T of alpha 1 plus beta 1, comma, alpha 2 plus beta 2. Now, according to the given structure of T, just look at T. Txy means x plus y and x minus y, that is component would be added and the components would be subtracted, right? So these are the two components. So in the first case, they would be added like this. And in the next case, they would be subtracted like this. Right. Okay. Now, let's break these vectors into two vectors. Now the game begins. Khela hobe is quite popular nowadays. Let's see. Just break this vector into two more components. I'm just breaking it. And next I will validate the break. Just tally this vector with this. Are they same? Entirely. Alpha 1 plus alpha 2 plus beta 1 plus beta 2. The first component. And the second component, alpha 1 plus beta 1 minus alpha 2 minus beta 2. So this vector is same as this vector. Now, what is this vector? The components are added and the components are subtracted. The components are added and the components are subtracted. Can you find any similarity? Yes, indeed. Txy is x plus y and x minus y. X plus y, x minus y, x is alpha 1, y is alpha 2. So this is T alpha 1, alpha 2. This is T beta 1, beta 2. Now alpha 1, alpha 2 is alpha curl and beta 1, beta 2 is beta curl. So look at this, pretty easy. T alpha curl plus T beta curl has now become T alpha curl plus T beta curl. So the first criterion to become a linear transformation, it's validated. Now the second criterion, T of C alpha curl would be C of T alpha curl. Okay, let's check. Alpha 1, alpha 2. Okay, so C alpha 1, C alpha 2. Fine. Components would be added and components would be subtracted. It's a vector, so we can take C outside. Once again, components are added, components are subtracted. So this is T alpha 1, alpha 2. This is nothing but T alpha curl. So T of C alpha curl is nothing but C of T alpha curl. Okay, so we can say that T is a linear transformation. Now you must be wondering, I have really wasted so much time. Yeah, I have, but it's the beginning, and beginnings should not be hasty. In cricket basic, no one starts from learning how to do a switch hit. No one does, right? So when you are learning a subject, just go step by step. Don't learn tricks, learn the topics. Tricks you can find out yourself. Okay. Anyways, this thing I could have verified in two ways. The first way is this alternative definition. T of alpha C curl plus beta D curl would be alpha of T of C curl plus beta of T of D curl. That's a punch between your criterion 1 and criterion 2. So the previous problem we could have solved using this trick. Okay. Another trick we could have used. Another trick. That's a mental trick. Now look at this linear transformation. They all are linear functions. So this is quite eligible to be a linear transformation. But I'm giving you one example. I'll not prove it. I'll just leave this proof for you. Just for example, Txy. Okay, let's put example like this. T is a mapping from R cube to R cube. That is three-dimensional real plane to another three-dimensional real plane. And the structure is YZ ZX XY. Now apply your common sense. YZ ZX XY. This structure is definitely a non-linear type structure. Highest power is 2. The power is 1 multiplied by 1. So power is 2. It's breaching the linearity property. So this is not a linear transformation. In many jam problems, in multiple of jam here, you may see that a question like this. Which of the following is not a linear transformation? Then 4 options. You need not to solve in your copy. Just by eye observation, you can solve the problem. In later class, in some other day, I'll tell you, I'll give you example of jam problems. But if one option is like this, I need not to solve any problem in pen and paper. Directly, I can say, this is not a linear transformation because non-linear structure is here. If you're still skeptic, let's take one example. Okay, let's take alpha curl. Let's take beta curl. T of alpha curl plus beta curl is T of alpha 1 plus beta 1. Alpha 2 plus beta 2. Alpha 3 plus beta 3. Now, according to this structure, yz, zx, xy, alpha 2 plus beta 2 into alpha 3 plus beta 3. Then alpha 1 plus beta 1 into alpha 2 plus beta 2. Then alpha 1 plus beta 1 into alpha 3 plus beta 3. Okay, just like this. I'm using the next page. Yz, that is alpha 2 plus beta 2 into alpha 3 plus beta 3. Then yz, zx, okay. So zx means alpha 1 plus beta 1 and finally xy, alpha 1 plus beta 1 into alpha 2 plus beta 2. Clearly this is not same as so this is not a linear transformation at all. Okay, but you need not to solve this much in your copy. Clearly by eye observation, we can say this is not a linear transformation. Okay, that's the very primary idea regarding linear transformation. Now, whoever watching this video live, in the live comment box, just tell me the first problem. I was in the n-dimensional real plane and I made a mapping to one dimension. What was the transformation? Is it a linear transformation? Share your answer in the comment box. So I guess now you can identify which mapping is a linear transformation and which mapping is not a linear transformation. That's a very primary class. Very, very primary. After that, you have a few topics, rank nullity theorem, kernel, etc. But that's a bit high topic than this basic class. So maybe we'll come back on Saturday evening for this class. Till now, please in the comment box, let me know, have you enjoyed the class or not? Obviously, I'll be commenting more about the applications. Today, I just told you a few applications, but there are a lot more applications of linear transformation. So, and that's quite fascinating one. So please do let me know what topic more you want to learn. Someone said in the last comment box that they want to learn biostatistics, but let me tell you one thing, biostatistics is quite a vast topic. So you have to tell me which topic you want to learn. Okay, so you really have to understand that statistics, the learnings, they are quite a broader one. And you have to shorten up the concepts gradually. And then you have to make the progress step by step, one by one. Okay, so today's class, let us just stop here today and we'll come back to maybe some next day, Saturday. Thank you all.